Okay, this is the video for section 7.2 part 1, and the second section in chapter 7 talks about finding volume. Okay, so here's what we know so far. 7.1, we had to find the area between two curves. So I could find, if I had these two curves, I knew how to find the area of this. If this were in terms of x, it would be my upper term minus, or my upper curve minus my lower curve. So what they're going to do now is we're going to find the volume um, of, let's say, these two curves when they are being either rotated around a certain line or when they give us what they are going to call a cross section of that curve. Okay, and so if I were to rotate this around a line, I'm going to get a three-dimensional shape, and we're going to be finding the volume. When I'm given cross sections, I'm going to show you what that looks like. First of all, when you're given a cross section, you're always going to draw the cross section perpendicular to the axis of revolution. Um, Before we get into that, we're going to find the volume by the method of slicing. Okay, so I'm just going to show you some pictures of what I'm talking about. The first example would be this one. Okay, this is y equals the square root of x. Okay, and probably I think it's going from 0 to 9. They're using semicircles as their known cross section. So you see how they're having a semicircle and they're placing it to where the base of it is covering that square root of x function, and they get this three-dimensional shape. Okay, so again, here's the square root of x from 0 to 9. The semicircle is what they're going to say is the cross section that we are using. And we can build this three-dimensional shape using a semicircle that's filling the base, and this base is the shape of the square root of x. So that's kind of what that looks like. Let me show you another example. Let's do an example of an equilateral triangle. Okay, here's the sine x curve. Looks like it's from 0 to probably pi. This time they're using equilateral triangles as my cross section, and see the three-dimensional shape that that is forming. And we can find the volume of that shape. Okay, again, and they're going to show you, and again, my y equals, it was sine x, probably from 0 to pi. And they told us to use equilateral triangles to fill in that graph so that we come up with a three-dimensional shape. Okay, so I'm going to let it go through again so you can see what kind of shape that will create when I use equilateral triangles. Now I can use lots of different shapes. A lot of the times the most common would be semicircles, squares, equilateral triangles. So I could use the same shape, but this time use a square, and it's going to look a little different. Okay, and I don't know, I don't think they showed that particular one. Now I'm going to show you when they do use a square. All right, so here base is a quarter of a circle of radius, so this is a quarter of a circle. My cross section is going to be a square, and that is the shape that you're going to come up with, and I'm going to be finding the volume of that three-dimensional object. Okay, so as we're looking at this, does it make sense that I know how to find the area of a square? That's pretty easy. Area of a square is my base times the height, and square, the side's the same, so it's s squared. All right, so here's the thing. If I could find basically the volume of each little square, and do you see that if I find the area of this red square and multiply it by its thickness, that would give me the volume of that one square. Then I could do the blue one, find the area of that, multiply it times its thickness, and then I would be adding up all these different colored squares. Well, that means that this is an integral because when we integrate something, we are adding up, just like when we added up all those little rectangles whenever we were finding the area into the square. That's what we're doing here. Okay, we're adding up all of these little volumes of these little tiny squares. Okay, let me show you one more example. Um, let's do, we'll do this one. Okay, it's a circular base of radius 2. And we will actually build some of these later on. They're using equilateral triangles. And that's the three-dimensional shape that you're going to end up with. And we can find the volume of that by using the area of an equilateral triangle. So when we're finding volumes, given known cross sections, and our cross section will, like I said, be squares or semicircles or equilateral triangles, we have to know the area, how to find the area of those things so that we can add up all those areas. All right, so what I want to do is, here's what we need to talk about. The volume of a solid of known integrable cross sections from A to B is the integral from A to B of the area. So to find the volume, we need to find the area, and then we're going to integrate that from A to B. Okay? So how to find the volume by the method of slicing or cross-section. Sketch the solid in a typical cross-section. Find a formula for the area. Find the limits of integration, and then integrate the area to find the volume. So the first thing we're going to do is we're just going to practice area formulas. And I know this seems pretty simple, but it gets a little, maybe a little confusing when you're not used to just a normal area formula. All right, so the following are common area formulas that are used. Okay, a square with sides of length x. Well, this one's easy. If I have a square, we know that all four sides are the same, actually they used x's instead of s's. So if I want to find the area, it's base times height, x times x. So the area would be x squared. Okay, a square with diagonals of length x. And I have to find the area of this square. Well, this one's a little different. First of all, I know this is a right angle. So if this is the diagonal, it's going to split this angle right here in half. So now this is 45 degrees right here and 45 degrees here. So I have a 45-45 triangle. Well, if you'll remember, your 45-45 triangle has sides of length A, and A radical 2. So if this side right here is x, which is A radical 2, how do I find just A? Well, to find just A, wouldn't I divide that by radical 2? So this side has to be x divided by the square root of 2. So this side is x squared root of 2, this side is x squared root of 2. So the area of that square would be my base times my height, which would be x squared over 2. Okay, a semicircle of radius x. Well, this should be easy. That's a nice little circle there, isn't it? There's x. We know that the area of a full circle is pi r squared. My radius is x, so that's going to be pi x squared. That's the area of a full circle, so a semicircle would be half of that. And again, the reason we're going over these is because they're going to be using a square, a semicircle, an equilateral triangle as their cross section. So you're going to have to be able to figure out the area of that cross section. Okay, a semicircle of diameter x. So I'm going to go ahead and draw my full circle. So if the diameter is x, that means the radius has to be x over 2. So we know the area of a semicircle would be 1/2 pi r squared. Okay, and if I wanted to simplify that, 1/2 pi x squared over 4, which would give me 1/8 pi x squared for the area. Okay, number 5, an equilateral triangle. So equilateral triangle, even though they may not look the same, all three sides are the same. And my length is side x. Now we should know that the area of a triangle is 1/2 my base times my height. And remember, your height has to be perpendicular to the base. So I don't have my height yet. So here's the deal. I know that this side is x, this side is x. Okay, so um, let's just use this side of this triangle. Okay, well, if it were equilateral, that also tells us that this was 60, this was 60, and this whole angle was 60. But when I dropped my height, then it's going to divide this angle in half. So now this is 30. So now I have a 30, 60, 90 triangle. Okay, well, my hypotenuse is x, and if you'll remember, in a 30, 60 triangle, um, this is 30, 60, this is a is always opposite my 30, this is a square root of 3, and this is 2a. So let's figure out what we have. Well, 2a was x, so to find side a, that would just be x divided by 2. And then this would be what? X, um, so if this is 2a, this is x divided by 2, and then this side is a square root of 3. So my a is x over 2 times the square root of 3. So a square root of 3, I'm just checking my work here, 2a. So the area of this is going to be 1/2 my base, and my base is x over 2, times my height, and my height is x over 2 times the square root of 3. For some reason, I think I have an extra 2 right here. So that's x squared square root of 3 times 8. That's not looking right to me. I'll go back and check it. If you see anywhere where I made a mistake, let me know, and then we'll talk about it in class. I have down, this should be a 4 right here. So I'm wondering about this 2 right here. Okay, we'll go back and look at it. All right, number 6, an isosceles right triangle. So I have this right triangle. Isosceles means that I have two sides that are the same. So if I have two sides that are the same, this must be a 45, 45. A 45, 45 is a radical 2. Okay, so, which I don't even really need to know that. But my area is 1/2 my base times my height. So 1/2 x squared. Number 7, an isosceles right triangle with hypotenuse x. So I'm going to draw that same triangle. Okay, again, it's a 45, 45. My hypotenuse is x. So remember that this is a square root of 2. This side would have to be x over the square root of 2. X over the square root of 2. So it's 1/2 times my base times my height. X squared over, what, 4? And a triangle, and I'm looking here, with sides 3x, 4x, and 5x. Okay, and I didn't specify that it's a right triangle, but doesn't it make sense that that would be a right triangle, 3, 4, 5? So 3x, 4x, 5x. So it's going to be 1/2 times my base times my height. So that's going to be 12x squared over 2. So the area would be 6x squared. Okay, so we went through that because we're going to have to know how to find the area of these shapes when we're finding the volume of a known cross section. Okay, so what I want you to do is on your worksheet, I want you to try to write down the area formula for problems 1 and 2. Okay, you have a part A, B, and C, and D, but that's what your assignment is going to be. I'm going to help you, but you need to at least attempt those first.